In this lesson, you'll learn how to find intersections of a couple different types of functions by creating a table, and then we're going to also talk about how to do it by graphing. Okay, so if you do not have, a calculator or Desmos available, you'll have to usually create a table to find the intersection of two functions. And so, first of all, intersection means that you're looking at where they cross. What x and y value do they have in common? Okay, so remember, intersections is where the two functions cross in their graph, or you could also think about it, you're looking for the x and y values that they have in common. Okay, so where the two functions cross. Okay, so if you're creating a table, you'll have to make a table for each function, and then you're going to look at which x and y values they have in common. Okay, so just to have an example, let's say that you have the equation y equals 2x plus 1, and you have the equation y equals x squared plus 1, and they ask you to find the intersections of those two functions. Well, one thing that you could do is you could create a table of values for each function, and you're going to compare them. So if you kind of remember what we talked about before, it does help to know what types of functions you're dealing with. So if you just have an x that has an exponent of 1 and it's not like part of a fraction or under a square root or anything, then that's a linear function. So we have a linear function here. And then this one, it has an x squared in it, and that is the highest exponent that you have, is that 2. And so when you have that, that's a quadratic function. And so if you think about the graphs of a linear and a quadratic, the linear is a line, and then a quadratic, remember, looks like a U. And if you think about what we talked about before, if you look at the number in front of x squared, it's going to tell you if it opens up or down. So this one, because the number in front of x squared is a positive 1, if it's positive, it technically means it opens up. And so you kind of know, if you graphed it, what it would look like. Okay, so what would happen if you make a table? All right, well, remember, when you make a table of values, then you're going to choose x and y values, or excuse me, you're going to choose x values to plug into the equation. And when you plug them in and you simplify, you'll get the y values. Okay, so we're going to make a table to represent our linear function, which is the y equals 2x plus 1. And then we're going to make another table for our quadratic function. And then we're going to see what coordinates they have in common. So typically, I had talked about, you usually start with, I start by plugging in some negative numbers and 0 and positive numbers, and then I kind of go from there, okay? So that I can see kind of what the graph is going to start to look like. So I could start by plugging in -2, -1, and I usually go at least maybe to 2 or 3. So I'm going to plug those in one at a time to get my y values, and then I'll do the same thing over here. So I'll plug in -2, -1, 0, 1, 2, and 3, and then I'm going to look at what they have in common. Okay, so when I plug in -2, you take the equation, and whenever you see x, you're going to plug in that number. So for this one, I would have 2 times, plugging in my -2 plus 1, and then you simplify. So that would be -4, and -4 plus 1 ends up being -3. And then if I do the same thing with the -1, it would be 2 times -1. So 2 times -1 is -2. And then -2 plus 1 ends up being -1. And then same thing when I plug in 0. 2 times 0 is 0 plus 1 ends up giving me 1. When I plug in 1, 2 times 1 is 2, plus 1 is 3. So I'm just plugging in each x value. When I plug in 2, 2 times 2 is 4, plus 1 is 5. And then when I plug in 3, 2 times 3 is 6, plus 1 is 7. And then also, if you remember, linear functions will increase or decrease by the same number. If you realize that, you can find kind of what it's going up by or down by, and you would have been able to figure that out what the y values would be after a certain point. So don't forget about that. So now we do the same thing, but with this function. So now I'm going to plug in my -2 in here. So if I did that, it'd be y equals, I'm plugging in a -2 this time, so it'd be -2 squared plus 1. Okay, so -2 squared would be like -2 times -2. So that would be a +4, and then 4 plus 1 is 5. And then if I plug in a -1 now, it'd be -1 squared, which is 1, and 1 plus 1 is 2. If I plug in a 0, 0 squared is 0, plus 1 is 1. When I plug in my 1, it'd be 1 squared plus 1, so 1 plus 1 is 2. And then if I take 2 and plug it in, 2 squared is 4, plus 1 would be 5. And then 3 squared is 9, plus 1 is 10. Okay, so now one thing that you could do, just so you can visualize it, is you could take these coordinates for the line and plot them. So if you needed to kind of visualize what was going on there, so I could plot -2, -3, 1, 2, 3, be right there, -1, -1, 0, 1, 1, 3. All I'm doing is plotting the coordinates that I just got from my line. 2, 5, 3, 1, 5 would be right there. And then I have 3, 7, so 3, and then got to go 2 more up to get to 7. So that's kind of like my line. That's what my line would look like. So I'll kind of draw a line ever so lightly there. All right, so that's what my line would look like. And now I could graph the quadratic on the same graph, and that would kind of let me visualize where they're crossing. And then you'll see why, you know, if I just look for what they have in common or which coordinates they have in common, it'll make sense. So if I start kind of graphing this, -2, 5, so -2, 1, 2, 3, 4, 5 would be about right there. -1, 2 would be right here. 0, 1, so notice that's going to be where they cross, or one of the points where they cross. 0, 1, and then 1, 2 would be right here. And then 2, 5, 2, 1, 2, 3, 4, 5. Oh, that's another point where they cross. And so it is helpful to do this on a grid because, you know, notice drawing it by hand sometimes can mess with you. And then 3, 10, 3, and then I think that was at 7. So let's go up 7, 8, 9, 10. That would be right there. So when I graph this, and remember quadratics are symmetrical, so it's going to look kind of the same on both sides. You can see in my graph that they cross right here, and I think it was right there. Okay, so you could see it in the graph, but then you could also see it in the table. Look, notice they share this coordinate in common, and they also share that same coordinate. So those would be the 2 points where they intersect. And so your answer for the points where they intersect would be at 0, 1, and at 2, 5. Okay, so that's how you create a table, and you could also kind of create your graph from creating the table. Okay, if you, for instance, had Desmos available or a graphing calculator available, then you could also graph it on Desmos or the calculator. So what I've done is I've went ahead and put in those two functions. So notice all I did is I typed in my y equals 2x plus 1. And then I typed in y equals x squared plus 1. And so it went ahead and graphed it for me. And notice you can kind of zoom into your graph, and you can see where the points where they cross. And then for Desmos, you could actually just click, and you will notice that it'll show you where they cross. And so you could have also got it by doing that, okay? But sometimes you have a calculator or a Desmos available, and sometimes you don't. And so you have to kind of know both ways. But that is how you create a table to find the intersections, and it's also how you can graph it using a graphing calculator.